One of the many benefits of virtual machines is that you can migrate a computer from one hypervisor to another. The only catch is if a VM is relying on a USB device, because then the USB device will be plugged into a specific hypervisor and the VM will then be tied to that hypervisor. Now, there are various offerings out there that you can pay for which allow you to share a USB device over the network. But if you're using Linux computers, you can do this all for free. But how do you actually set up and configure a Raspberry Pi, for example, to act as a USB server and configure a Linux client to then access the USB device that's on it? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, because this video is more about how to set up USB over IP, I'm going to make an assumption that you already know how to install the Raspberry Pi OS. If not, then I do have another video available which shows you how to do that. Having said that, you don't necessarily need to use a Raspberry Pi as your USB server, because the commands that we're going to be using should work on any distro that's based on Debian. Now, I will be including a link to a particularly useful blog that I found on how to set this up. But I'm also going to include another one which shows you how you can also set this up on Arch Linux if you prefer to use that instead. Now, the first thing that we need to do is to set up a USB server. And in my case, I'm going to be using a Raspberry Pi. So I've installed the operating system, I've turned it on, and I've now logged into it using SSH. But before I start installing or configuring USB over IP, I do want to make some slight changes to this computer first. One thing I want to do is to change the password for the root user account. So that's sudo passwd then root. In other words, I'm telling it that I want to change the password for the root user. Hit return, put in my new password, and just confirm that. Part of the reason for doing that is I don't know what that password is, but I do actually want to switch over to the root account anyway. That's going to make my life easier when I start configuring this. And I just don't like leaving default settings, basically, if I can help it. When this operating system was configured as part of the original installation, I was never asked what's the actual password you want to use for root. And I would prefer to know what that is, so that's why I've changed it. So now that we've got that changed, next thing I want to do is to give this computer a static IP address. The reason being is that when we set up the client computer, we need to point it to this computer. We need to tell it what its IP address is, and it's not going to work basically if it keeps getting changed in DHCP, for example. Now, you could, for instance, reserve it in DHCP if you like, but in this case, we're going to just give it a static IP address. So what I need to do is edit a configuration file on this computer. So I'll just paste that command in, make my life easier. So we're editing the dhcp cd.conf file in the /etc folder. I'm going to go right to the bottom just to make life easier. There's already an example of how to actually configure one of these static IP addresses, but I'm just going to paste in what I need for this particular computer on my network. So I've set its IP address here, told it what the default gateway is, and I'm pointing it to some DNS servers on the internet. In this case, one's belonging to Cloudflare, because this doesn't need to know anything about my internal network, in which case I'm not going to give it access to my DNS servers. So I'm going to save those changes. That updates the configuration file. So next thing I need to do is, to get all this to actually take effect, is to actually reboot this actual computer. So I'm going to type in reboot now, hit return, but I need to do that using sudo rights, and then off it goes. Well, the Raspberry Pi is now back up and running, except this time it's got a static IP address. So what we need to do now is to install the actual software we're going to be using. So first thing I'm going to do is switch over to the actual root account. So su switch user space, then just a hyphen or dash, hit return, provide the password. Next thing I need to do is to install the software. So that's apt install USB IP. And I'll say yes to install it. Now, the next thing I need to do is to actually load the module for this. So that's modprobe USB IP underscore host, hit return. But I want to make sure that this always gets loaded whenever the computer starts. So we put in this command to basically copy this name of the module over to the modules file that we've got there in the /etc folder. And that gets our software installed, set up, and ready to use. Now what the software does is give us a command that allows us to bind and unbind a USB device to the server. But the first thing we need to know is some details about the actual USB device, or devices if you want to attach multiple ones. There's different ways to do this. One command we can use is USB IP list-L. That gives us a list of USB devices that are locally connected. Now, as far as the command itself's concerned, it's interested in these bus IDs. So I've got two USB devices I'm going to use in this demo. One's just a USB flash drive, and the other one's an actual Z-Wave AOTech Z-stick that I've got here. So there's different ways you can do this. What I want to do actually is take advantage of these product IDs and vendor IDs. That way I can identify the device itself. Doesn't really matter what port it ends up in. If these change at a later date, if I decide to swap devices over, replace them with something else, I can always update these. These are a bit easier to identify. It makes the process a bit more complicated, but we can actually do this with a script. So what I'm going to do is create two scripts. One which binds my USB devices and one which unbinds them. So the first one, I'm just going to use nano to create this script file. Just paste that in. So I'm just going to call this USB IP underscore start.sh. I'm putting it in the /user/sbin folder because that just happens to be where the command happens to be installed. So I'm just going to hit return. And then I'm going to actually paste in the details for this. It's a bit complicated, I must admit. It's basically taken from the way this was set up on the blog that I was looking at, but also on the Arch Wiki Linux. They use a similar sort of process, but I'm trying to simplify things with a script here. So what I've got is, I've got one USB device, and that's the vendor ID and the product ID for that. And then I've got a second one, and that's its details. And I'm basically using those in this command here, where basically we run the command to bind the actual USB device. But what it does is to actually run the command to actually list details about the USB devices. And it actually uses that product ID and vendor ID that we've got and essentially cuts that out so that it's all that it's got left is just details of the actual bus ID. So I've repeated that down here. So I've got one line for USB 1, USB 2. So I'm going to save those details. And then what I need to do is I actually need to make sure that that file is executable. So I need to give it the modify there +X. I also want to create my stop script. So that one is going to go in the same folder, except I'm just going to call it USB IP underscore stop. So it's kind of similar, except it uses the unbind parameter. So let's copy that, paste that in. And this has just got an extra line in it because basically I'm going to turn this into a service. So in the examples, if you go through the blog or if you go through that Arch Wiki, they're just binding one device, but I want to actually do two. So I've broken this all down into a script, and I'm including the extra line in there to kill all the processes for that USB IP daemon there. So this is basically just the same as the previous script, except this one does the unbind as opposed to the bind. And then I need to make sure that that's executable as well. So we'll run that. And that creates a start script which binds the actual two USB devices, and then a stop script which unbinds them. So the next thing to do is to actually test that these scripts are actually working. So I'm going to run the start script. So let's copy that and paste that in. So basically we just have a dot and then the entire path for our actual script file. And I'll hit return. So it's come back and it's telling us now that we've actually got two USB devices and now actually bound to our service, saying that the process is complete. I'm not seeing any errors there, so that's a good sign. So now we'll test the stop script, make sure that that one works. So while that one binds, this one unbinds. So this one's come back and telling us basically the same as the same bus IDs as before, except this time getting told that these have actually been unbound. No errors to report by the looks of it. Process has come back complete. I'm not too concerned about this line here because that's to do with when we've actually got this running as a server, so that's fine. So as long as there are no errors, those scripts are good to go basically. But one thing I'll point out is the reason I went down this particular path was I was just thinking ahead in terms of maybe I want to add more USB devices. It would be a case of adding an additional variable here, for example, and copying one of these lines. If one of these devices changes, all I need to do is make the change here. Gives me a bit more flexibility, so that's why I've gone down this particular path of using script files. I think it makes more sense, especially when you get to the client side, because there's a bit of replication going on as well. Less likely to make errors, I think, if you're going to running as a script file like this, for instance, than defining all of this within the actual service file itself. So the next thing to do is to create a service file. This way we can automate all of this binding and unbinding of our USB devices. So I'm going to create the actual file using Nano. I'll just copy and paste this in. So we're calling this USB-IPD.service. And then I'll paste in the details about this. So the key points are that we're basically going to start the USB-IPD daemon here. And then after that, what we're going to do is we're going to run our start script. Now, if the service stops, we then want it to actually run the stop script. So we'll save that. And that gives us our service file. Now the goal here is that when this Raspberry Pi boots up, we wanted to start a service to actually bind those USB devices to our USB IP server, and then they'll be available over the network. So first thing we need to do is to let the system know about that service we've created. So I'm pasting in this command systemctl -- system, then daemon reload. I'm then going to give it a command to make sure that our service always starts when this Raspberry Pi is booted up and it's up and running. So that's what the enable parameter is for. And then we're actually going to start our service. So it hasn't come back with any errors, but we can actually just double check to see if it's running okay by giving it that status parameter instead. So it hasn't complained, so that's a good sign. So the next thing to do is to start configuring the client. Now the client's configuration is fairly similar to what we did for the server. In my case, I'm actually using a Debian operating system, but you could use some variant of that. First thing I need to do is to switch over to the root account. I'll put the password in for that. And then once I've done that, I'm actually going to just double check while I'm here just to make sure that there are no USB devices already attached. So it gives me a sort of like a baseline to know what USB devices this computer already knows about. Next thing I'm going to do is to actually install the software. So there is some additional software that we need. So with the server, we just installed USB IP. With this one, we're also installing this HW data and the USB utils as well. So if it goes and installs the software, so as before, we want to automate this process, but it's a different module that I need to load for the client. So I'm going to run this command modprobe vhci-hcd instead. And again, we want this all automated. So I need to tell it about this module to get it to actually load that on start. So that's now got our software installed. Now the next thing to do is to create some script files. One which is going to be to attach the USB devices, and the other one's going to be to detach them. The reason I'm using script files is just to make things easier, especially in terms of like future-proofing, in the sense that I might decide to change an IP address of the actual server, might change vendor ID so I can use a different USB device, add more USB devices, and so on. So first we'll do the script which is to start the process. So I'm just going to use nano to create this file here. And then I'm going to paste in the commands that I've got. So basically what I've done here is to define the actual server. The reason being is it actually gets referenced multiple times within the command. And then I've also got the actual product ID and vendor ID of the USB device. So the first line is for device number 1. The second line is for device number 2. So if you look at the actual examples on the blog or in the Arch Wiki, for example, they do all this within the actual service file itself, and you could do it that way. But I think this to me is an easier way in the sense of the future proofing, because if I want to make changes, I just need to change the variables rather than have to go through each of these individual lines piece by piece. It also makes it easy to add things on afterwards. So that's my first script file done, but I do need to make sure that that's executable. So I just use the chmod command to give that an executable parameter there. And then need to create one to actually stop things as well. So this is to detach the USB devices. So I'm calling this USB IP_stop. Now this one's actually a lot simpler because all it does is actually it looks to see if any ports are actually in use. And then all it does is just detach them. So there's no reference to any of the specific USB devices. The expectation of this is that we're going to be stopping the service, and therefore we actually want to just detach all of the USB devices cleanly. So like I say, there's no reference to the server, there's no reference to the USB devices themselves. It's just going to have a look and see what's attached and detach it. So I'll save that file. And as before, I need to make sure that this is executable because it's going to be a script file. So that creates our start and stop scripts. Well, the next thing to do is to actually test these script files to make sure that they're working. So we'll start with the first one, which is to attach our 2 USB devices. So we're just literally going to run that script file. So it hasn't come back with any information, but if I run the command USB IP port, it's telling me that it's imported 2 USB devices from our server. So one is our Cruiser Blade, our USB flash drive made by SanDisk, and the second one is our Z-Wave controller, which has been made by EOTech. So that looks good. Now what we want to do is to actually detach them. So we'll run our stop script. So it's come back and it's actually said that they are now detached, but I am just going to run that command again just to be on the safe side, make sure that those devices have been properly detached. I'm also going to run the command lsusb, if I can type properly, just to make sure it's not showing up in here at all, because I have found inconsistencies here when I was earlier trialing this, because I would run the stop script and then I would run the start script and I would get an error message popping up. Now, what I was then finding was that one of those devices was still showing up as being attached, even though the actual stop script had run and supposedly detached it. What I've been reading is that can happen when you've got a discrepancy in the version of the software that you're running. So I've since upgraded the software on this Debian computer. So both the Raspberry Pi and this Debian computer are fully up to date. I've run this a few times now, and I'm not getting that error message before, but it is something to bear in mind, is that if you do run that start script and it complains, for example, for whatever reason, it's probably due to a mismatch in the software version. So it's just something to bear in mind. Now I want to automate this process because I want this computer to boot up, and once it's up and running, I want it to attach those USB devices on my Raspberry Pi, in which case I need to create an actual service file so I can run those scripts as part of a service, so it's all automated. So I'm going to use Nano to create my service file. Then I'm going to paste in the details for the service. So it's pretty much the same as what we did for the server, really. So basically I wanted to run this command, the start script, when it actually starts the process. And I wanted to run the stop script when the actual service gets stopped. So I'll save that. And that creates our actual service file. So now that we have an actual service file, we want to actually tell the system about it. So I'm going to copy and paste a command in for that. So that is systemctl --system daemon reload, hit return. And because we want this all automated, I want to make sure that the service starts on boot. So we'll paste the command in for that. So that's what the enable parameter is for. Now, that gets that part done, but while we're here, we may as well just get it actually started now. So pretty much the same command, except we're using the start parameter to tell it to start the service now. And then we're just going to do a quick check just to see if it's running properly. There's no errors reported. So we'll do USB IP port. If I could type. So we've now got our actual two USB devices attached, but they've been attached as part of the actual service. So now this should all be automated and ready to go. So we've now got an automated system where we've got a client here, a Debian computer, can gain access to USB devices that are actually plugged into a Raspberry Pi. The benefit that I see is that if I set up some virtual machines, I can actually get the virtual machine to gain access to this USB device over the network, for example. So instead of plugging a USB device into the hypervisor, the virtual machine will get direct access itself. So it gets rid of that problem of having a virtual machine tied to a specific hypervisor because it's reliant on a specific USB device. There are other benefits because you can actually share an actual USB device over the network among multiple computers. Just bear in mind though that only one computer can use a device at the specific moment in time. So if you've got, say, like this Debian computer, for example, is using that USB flash drive, if you want another computer to use it, we're going to have to disconnect it from this computer first, and then we'll actually attach it on the other computer so that it can use it. In those sort of circumstances, you probably want to do a manual process rather than services, but there's quite a bit of flexibility here. In my case, I'm more interested in virtual machines, which are going to be running 24/7, but it's something to bear in mind. We can improve the security here. For one thing, that Raspberry Pi, you could put UFW on the actual computer, allow access to TCP port 22, restrict what computers can get remote management access. We also want to lock down access to the actual USB IP service as well. And if I run USB IP port here, it actually tells us that it's using port 3240. So we can actually restrict which computers can gain TCP access to port 3240 on that Raspberry Pi to deal with potential software vulnerabilities and that sort of thing. So that's something else to think of. You've also now got this dependency, if you're automating it, whereby we've got the server needs to be up and running first. Once that's actually up and running, it'll share those USB drives. Once that's available, then you would start the client. So there is an order to actually starting your computers. Likewise, it's the exact opposite when you want to shut things down. You disconnect the actual devices from the client first before you think about doing maintenance to reboot the actual server, for instance, because you want a clean separation between these two computers. So these are just things to bear in mind, but overall I'd say it is definitely beneficial as far as I can see, especially for virtual machines. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, as that'll help get the video out to more people who might find it useful as well. If you've got any comments or suggestions, please post those in the comments section below. And if you're new to the channel and you'd like to see more content like this, then yes, do subscribe. Just remember to set the bell icon to actually send you notifications when new content gets released. Although I also post to Twitter as well as Facebook. If you'd like to help the channel and support it, you can actually make contributions through PayPal and Buy Me a Coffee. I've also got links to Patreon, and there's also the join membership option for YouTube itself. Patreon and YouTube members do have the option to actually benefit from early access as well. But above all, many thanks for watching this video. I'll see you in the next one.